In this video, we're going to talk about databases. Now, a database, we're going to be using MySQL. So, MySQL is a relational database, and that means it has tables in it, and these tables have rows in it, and these rows are related to other rows in the database. So they're all just a bunch of flat rows like an Excel spreadsheet or something. Now, this isn't a video about databases specifically as far as how to architect them or organize them or how to write SQL. I highly encourage people to go out and look a little bit about that. But fortunately for us, we're not going to be having to write SQL because we're going to be using something called an ORM to basically handle the SQL for us. Now, an ORM is an object relational mapper, and the object relational mapper we're going to use is nHibernate. nHibernate is a very popular ORM for .NET, and it supported the Java Hibernate that has been around for quite a while. So what exactly does an ORM do? Like I said earlier, an ORM generates SQL for us, and it hydrates actual objects from a database. So, for example, we might have an object that has a more object graph type structure. So we might have an object with other objects that are somehow related to some sort of root entity. And Hibernate's job is to take these tables and turn them in to an object graph. So we have the tables on the left in the database that's running on a database server, such as MySQL. And Hibernate grabs those tables and turns them into an object graph that we can consume inside of C#. So effectively what's going to happen is our controllers is going to tell Hibernate to hydrate an object graph. And Hibernate's going to ask the database to get data. And Hibernate's then going to morph those tables into an object graph. It's going to return them back into our controllers. Then our controllers are going to process them and send them into our views.
Okie dokie.
And remember that ASP.NET, MVC, is the one that starts the process through our routing. So our routing hits a controller tells Hibernate to hydrate an object graph, and Hibernate asks the database for data, the database returns that data, Hibernate munges it together into an object graph, passes it back to our controller then processes it and sends it back to our views, and then our views finally present that data on a website or individual web page. So that's just basically a conceptual overview of an ORM. There's another problem that we need to solve with our database structure, and that is our schema. Now, a schema in a database is essentially how that database is laid out. What tables are there, what columns are in those tables, what foreign keys exist, what the constraints are, what the indexes are, and so on and so on. We need a way to manage that. So what you're seeing right here, this diagram, basically describes how the data will work at runtime. But how do we version the database? Now remember, all of this stuff, oh, that's a terrible line. As you can see, I'm not really an artist. This is our code. And this exists in Git, our source control system. This is our database. This database does not live in our code. This database lives on the database server. The code runs on the web server. So we have a code/git. This is the web server. This is the database server. So the problem is that we need a way to create the schema from our code somehow. So how do we do that? Well, we do it through a process called migrations. Migrations are little scripts, I guess you can call them, that we can check into our source control system and manage our database's schema for us in an automated, predictable, rollbackable manner. So we have all of this stuff. So this is all the code get on the web server. But then we will also have our migrations, which will also exist in code, but they won't actually be inside of our web server. They won't be ran inside the web server. So I'm just going to say migrations. However, the migrations are separate. Although they still exist within our code, they're still code files that get committed to our repository. The migrations are actually separate scripts. So we'll have migrations. So we'll have migration 1, 2, 3, and 4, and 5, and so on. We'll be using migrations all throughout this. The migrations will be ran by a tool, and the tool will manage the schema. So we have two components here. Well, we're looking at three components essentially. We're looking at our database server. We're looking at what code is ran in our web server. Then we're looking at our migrations. And our migrations will be committed into the same project, but again, they won't be ran inside the web server. Instead, they'll be ran by an external tool that will update our schema for us on our database. How are you feeling about that, Steve?
Do you really want me to weigh in on this?
Maybe.
No, you don't, because I'm going to start a whole cake analogy, so don't even go there.
Cake analogy sounds good.
All right, fine. You asked for it. We started out with hydrating something, which is kind of like moist, and then we're going to consume it. So that's cake. And then we were talking about immigration. So we're talking about alien cake.
Alien cake. Okay, I need to write a migration runner called Alien Cake and open source it.
See what you get for asking my opinion?
Yeah. Well, at least I got like an amusing analogy out of it. The specific tool we're going to be using is actually called Fluent Migrator. And Fluent Migrator will simply take our migrations, run them against the database, and we'll get a schema out of it. Now, I know that what we're looking at is just a really high-level document. Obviously, I don't expect anyone to be able to jump in and start writing migrations and entities and schemas right now, but hopefully just keep this diagram in mind once we start working with these technologies, because it just shows the relationships between the different parts of our code and the different parts of our database. Remember, the goal is to have our database be managed by our code in its entirety. Not only the schema, but also the entities themselves. We're never going to be writing direct SQL against our database because we have nHibernate for that. Sound
Sure. Well, you know where I was, so yeah, this sounds awesome.
good? Alrighty, awesome. So I think that just about wraps up this diagram, and we'll see you in the next video.
Awesome.